Assalamualaikum warahmatullahi wabarakatuh. Today we want to present about the material science project. This is my team members Azlan Mustafa, Muhammad Izzuddin bin Muhammad Salimi, Nur Aina Afisha binti Aziz Bisruma dan Nur Atika binti Habib. Okay, this is the content that will be in our slide. First, have introduction, background, name of the application, advantage and compare previous material, processing method, then conclusion. Okay, first, my name is Nur Atika binti Habib. Today, I want to present about introduction. Bullet train is a high-speed passenger rail train. Since the island nation terrain restricts the amount of the usable space for roadway, public transportation is a crucial part of Japanese culture. The bullet train was designed as a high-speed rail system that would shorten the distance between major Japanese cities. The utilization of an aerodynamic form and technologies created to completely utilize the power of the train allowed the train to go at its high speed. Okay, for the background of the bullet train has been at the three places: first Japan, India, and Korea. For Japan, the Shinkansen is a high-speed intercity train system that has been in operation for more than 50 years and today spans more than 2,600 kilometers of rail length. Shinkansen, a trip from Tokyo to Osaka now takes just 3 hours and 10 minutes instead of the previous 6 hours and 40 minutes with the limited express trains. For the bullet train in India, midway through the 1980, a former railway minister had the original concept for bullet train in India. However, the plan was abandoned at that time because of the exorbitant cost of construction and the unwillingness of the passenger to pay a high ticket. For the high-speed train in Korean, the high-speed rail network in South Korea is a Korean Train Express, sometimes referred to KTX. It's operated by Korea. In 1992, work on the high-speed railway between Seoul and Busan got underway. On April 1, 2004, KTX service were made available. The KTX line branched out from Seoul Station to with station at Yongsan Station, Seoul Station, and Busan and Gwangju.
One of the applications of bullet train technology is Shinkansen. Shinkansen, also known as Japan's high-speed railway, has maximum speed up to 320 km per hour. The Shinkansen had once reached 443 km per hour in 1996. This bullet train runs in Tohoku Shinkansen connecting Tokyo with Aomori. Even though Shinkansen bullet train can speed up to 443 km per hour during test run, but the speed was fixed up to 300 km per hour for passengers' comfort. As we all know, the speed of this bullet train would make people. The material used for Shinkansen bullet train is 1. Aluminium alloy. Aluminium alloy are widely used for manufacturing Shinkansen bullet train and the other high-speed rail car to ensure high-speed performance with bodies that are both lightweight and high-strength. Secondly, duralumin alloy. Duralumin alloy are widely used in aircraft construction and also can be used in railways. Duralumin alloy are strong and lightweight alloy of aluminium. Duralumin alloy series that used in Shinkansen bullet train are 7000 and 2000 series to balance between the wall thickness and the strength of the train.
For the advantage of the using aluminum alloy in a bullet train is the net weight of the train can be significantly lower than any type of material like steel, and also aluminum alloy has extremely heat resistant to any heat, and it also have a resistance to corrosion. Next, this process is easily to manufacture and keep in perfectly in good quality. Aluminum alloy also are easily replaceable and appropriate for any surface of treatment. Lastly, the price of the aluminum is so reasonable. Now I will compare the aluminium alloy and steel for the bullet train. There are 4 aspects that we see, like cost, corrosion resistance, strength, and weight. For the first, cost, when creating any product, cost and price are always important factor to consider. Steel and aluminium price are constantly varying due to worldwide supply and demand, full cost, and the price and availability of iron and bauxite. Second, corrosion resistance. While malleability is significant in manufacturing, the most important feature of aluminium is that it is corrosion resistant, although after being polished. And we can see aluminium will not rust. Third, for the strength, aluminum is a highly demand for value metal to its greatness adaptability and elasticity than a steel. For the weight, lastly, steel is tougher than aluminium. Even with a danger corrosion, most of aluminium type of synthetic and alloy scratch more easily than a steel. So that's why we choose aluminium alloy than a steel.
All the bullet train have the aerodynamic features. All these high-speed train have streamlined shape to cut through the wind. The train nose also required to avoid the tunnel booms. High-speed train also using maglev or magnetic levitating system, which use 2 set of electromagnet, one set to repel and push train off the track, and another set to use the lack of friction to move the elevated train ahead.
So, the conclusion of our project is, after Japan has introduced bullet train technology to the world, several other countries like France, China, Germany and others have also brought bullet train as their one of the transportation in their country. Even though these bullet train are environmentally friendly, but it can be pretty expensive to build, especially for a small country. The bullet train will boost our economy and diplomatic relations. Hence, this will build relationship between countries and create a good relation, increase investment and increase trade. Construction for bullet train requires a lot of space. As for Malaysia, we have ETS train that are operated by Kereta Api Tanah Melayu Berhad. ETS route are from KL Central to Padang Besar. Though Malaysia's technologies are not too advanced as the Japan, but it is not impossible for Malaysia to become like them.